Hello everyone, welcome back to this channel. In this video, we are going to continue our discussion on question number 2, Cambridge International AS and A-Level Mathematics, Pure Mathematics 1. Now we have the following question. We are given the following diagram, and this diagram shows part of the curve with equation y equals k times sine 1 over 2x. Where k is a positive constant and x is measured in radians. The curve has a minimum point A, like this. The first question, we need to find the coordinates of A, which is the minimum point of the curve. Now, if you take a look here, the graph is actually the graph for sine 1 over x with the multiple of k here. That means the maximum value is k, and then the minimum value is negative k. Now, we know that the y-coordinate of A should be negative k. The next thing that we have to find is the x-coordinate of A. Because A is a point, that means we must have x-coordinate and y-coordinate, not only one of them. For the y-coordinate, it is negative k. How do we find the x-coordinate of A? If you take a look here, our equation is y equals k times sine 1 over 2x. And you can consider the periodicity of sine function. Periodicity of sine is actually equals to 2 pi over the coefficient of x here, which is 1 over 2. So that means this is 4 pi. It means that this is 0 and this is 4 pi. Because we know that the graph is symmetric, that means this is 2 pi, and then A is here, so it is the middle of 2 pi and 4 pi. That means it should be 3 pi for the x value. So we have found the coordinates of A, which is the x coordinate is 3 pi, and then the y coordinate is negative k. And we know from the question k is a positive constant, where k is positive, or we can say like this, k is greater than 0. Now we continue to question B. For question B, a sequence of transformations is applied to the curve in the following order. The first one we have translation and the second one reflection. Find the equation of the new curve and determine the coordinates of the point on the new curve corresponding to A. So we have two questions here. The first one is the equation of the new curve, and the second one is the new coordinates of point A after the transformations. First of all, let's see the transformations. The first one, we have translation of two units in the negative y direction. So our original equation is the following. So let me write down here. We have y equals k times sine 1 over 2x. Now after translation, we get the equation becomes y equals the translation of two units in the negative y direction. So that means you just need to subtract the y value by 2. So we can say like this, negative 2 plus k times sine 1 over 2x. The next transformation is reflection in the x-axis. So if you have the following, this is x, this is y, and you have a point here, x comma y. After you reflect it in the x-axis, the image of the point will be here with the coordinates of x, but for the y coordinate change to negative y. So that means after reflection, the y value becomes negative y and the x value stays the same. So negative 2 plus k times sine 1 over 2x. That means if you multiply -1 on both sides, you are going to get y equals 2 minus k times sine 1 over 2x. So this is the new equation of the curve. So let me write here. The equation of the new curve is y equals 2 minus k times sine 1 over 2x, like this. Now the second question, we have to determine the coordinates of the point on the new curve corresponding to A. Previously, we found that A has the coordinates of 3 pi, -k. So we need to do the following transformations on point A. First of all, after translation of 2 units in the negative y direction, it means, let me write here, originally we have 3 pi, -k, and then after translation, it will be 3 pi. You just need to subtract the y value by 2, so -k minus 2. And then once you do the translation, the next one is actually reflection in the x-axis. So you can use the same concept here. The x value stays the same, but the y value changes. So it will be 3 pi, and then it becomes k plus 2. So the new coordinates is this one, 3 pi, k plus 2. So that's the solution for question number 2. In the next video, we are going to continue our discussion on question number 3. Hopefully this video helps for all of you. Thank you very much.